Welcome to this lesson on NFT Metadata, IPFS, and decentralized storage. In this video, you'll discover how NFT data is stored off-chain, why this approach is essential, and how decentralized storage systems like IPFS make it all possible. Understanding metadata storage is crucial for anyone working with NFTs, as it determines how digital assets maintain their integrity, accessibility, and permanence in the blockchain ecosystem. NFT metadata is the additional data that describes an NFT's properties and characteristics. Think of it as the information card attached to your digital asset. Metadata typically includes 4 key components. First, the name and description, which provide basic identifying information about the token. Second, the image or media files, which are the visual assets that represent the NFT. Third, the attributes such as traits, rarity levels, and special properties that make each NFT unique. And fourth, external links that reference additional data or resources. Without metadata, an NFT would just be a token identifier on the blockchain with no meaningful information attached to it. When it comes to storing NFT data, there are 2 primary approaches: on-chain and off-chain storage. On-chain storage means the data is stored directly on the blockchain itself. While this provides permanent and immutable storage, it's extremely expensive and has strict size limitations. On-chain storage is best suited for critical data like token ID and ownership records. Off-chain storage, on the other hand, stores data externally from the blockchain. This approach is cost-effective for large files and offers flexibility and scalability. Off-chain storage is ideal for images, videos, and metadata files that would be too large and expensive to store directly on the blockchain. Most NFT projects use a hybrid approach, storing ownership on-chain while keeping media and metadata off-chain. There are 4 compelling reasons why off-chain storage is essential for NFTs. First, cost efficiency. Storing large files directly on the blockchain is extremely expensive due to high gas fees. A single high-resolution image could cost thousands of dollars to store on-chain. Second, size limitations. Blockchains have strict limits on how much data can be stored in each transaction or block. Third, media files. Images, videos, and audio files are simply too large for practical on-chain storage. A typical NFT collection with thousands of images would be prohibitively expensive to store entirely on-chain. Fourth, performance. Retrieving data from off-chain storage is faster and more scalable than pulling large files from the blockchain. This combination of factors makes off-chain storage not just preferable, but necessary for most NFT projects. IPFS stands for InterPlanetary File System, and it's a peer-to-peer distributed file storage protocol that has become the standard for NFT storage. IPFS operates as a content-address storage system, meaning files are identified by their content rather than their location. The network consists of a decentralized network of nodes spread across the globe, with no single point of failure. One of IPFS's most important features is that it creates permanent and tamper-proof files. Once data is uploaded to IPFS, it cannot be altered without changing its unique identifier. This makes IPFS perfect for storing NFT assets that need to remain unchanged and accessible indefinitely. IPFS uses a revolutionary concept called content addressing, which means files are identified by their content rather than their location on a server. Here's how it works in 3 steps. First, when you upload a file to IPFS, the file is hashed using a cryptographic algorithm. This creates a unique digital fingerprint of the file's contents. Second, this hash becomes the file's CID, or content identifier. The CID is a long string of characters that uniquely represents that specific file. Third, when someone wants to retrieve the file, they use the CID to request it from the IPFS network. Any node that has a copy of that content can provide it. Because the CID is based on the file's content, if even 1 byte of the file changes, it will generate a completely different CID. This ensures data integrity and makes tampering impossible. The typical workflow for using IPFS with NFTs involves 3 main steps. First, You upload both the NFT image and the metadata JSON file to IPFS. The metadata file contains information about the NFT, including a reference to the image file. Second, IPFS generates a unique CID for each file, creating an IPFS URI that looks like IPFS://QM followed by a long string of characters. Third, your smart contract on the blockchain stores this IPFS URI as a reference. When someone views the NFT on a marketplace or in their wallet, the application reads the URI from the blockchain and retrieves the actual files from IPFS. This creates a permanent link between the on-chain token and the off-chain data, combining the security of blockchain with the efficiency of decentralized storage. While IPFS is the most popular choice, several other decentralized storage solutions are available for NFTs. Arweave offers permanent storage with a unique pay-once, store-forever model. Instead of ongoing fees, you make a one-time payment to store data permanently. Filecoin is a decentralized marketplace for storage where users can rent storage space from providers worldwide. It uses economic incentives to ensure hosts keep data available. Pinata is an IPFS pinning service that provides managed IPFS infrastructure with easy-to-use APIs. It ensures your files remain permanently accessible on the IPFS network. Finally, Swarm is an Ethereum native distributed storage platform that integrates tightly with the Ethereum ecosystem. Each solution has its own advantages, and the choice depends on your specific needs for permanence, cost, and integration requirements. Let's review the key takeaways from this lesson. First, NFT metadata contains essential information about the token's properties and assets, including names, descriptions, images, and attributes. Without metadata, NFTs would have no visual or descriptive characteristics. Second, off-chain storage is necessary for large files due to cost and size limitations on blockchains. Storing high-resolution images and videos on-chain would be impractical and prohibitively expensive. Third, IPFS uses content addressing to create permanent, decentralized storage. Files are identified by cryptographic hashes rather than locations, ensuring immutability and preventing tampering. Fourth, smart contracts reference IPFSUR is to link on-chain tokens with off-chain data. This creates a seamless connection between blockchain ownership records and the actual digital assets. By understanding these concepts, you now have a solid foundation for working with NFT metadata and decentralized storage solutions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.